Hello guys, I'm Kavindra. In this video, I am going to design 4-bit adder with Logisim. Let's go to the video. So guys, you can remember in previous video I discussed about full adder. Here I am going to design this 4-bit adder using that full adder. If you didn't watch that full adder video, go to my playlist and watch that video first. That playlist link is available on this video description. As I said before, I am going to design this 4-bit adder using this full adder. Because of that, I need to convert this full adder circuit to sub-circuit. Let's see how can we do that. Here you can see this is the name of our this circuit sheet. I'm going to change this to full adder. You can see here, we can see circuit name. I'm change it to full adder. Now you can see it is changed in here. Now I am going to add new circuit. For that, right click this folder and click on add circuit. Let's rename this as a 4-bit adder. So our sub-circuit is full adder, 4-bit adder is the main circuit. So we need to convert this 4-bit adder to main circuit. For that, right click this 4-bit adder and you can see there is set as main circuit. Click on it. Now our this circuit is a main circuit. Now we are in our 4-bit adder circuit. Let's click once in full adder. Then not double click once in full adder. Then you can see like this icon. That means we can get our full adder as the sub-circuit to this 4-bit adder circuit. When I click on it, it is established here. Now you can see when you get mouse point over here, you can see A, B, CI, sum, CO. So you can see in full adder, this is A, B, CI. You can see it in here A, B, CI. And in full adder, this is the sum and CO, that means carry out. So you can see it in here, sum and carry out. So I think now you get the idea. So let's design simply circuit. So I am going to here get this wire out and I am going to simply check in this. My direction is this side. I need to convert it to downside. For that, I am click in my keyboard down arrow key. Then I can go get it to downside. You can do it also in this properties area. Facing is set to south. You can also doing it here. So let's connect this. I am copy and paste it. Control C V. Connect it to here. Connect it to here. Now you can see this is A, this is B, this is CI. A, O. I need to get this label also upside. For that, I go to this label location and set it to north. Let me select these other two and change it to north. Okay. B, C, I. Now this output. This one is sum, this one is carry out. Okay, now our assembly circuit is complete. Let's simulate it. You can see when you simulate it, it is working. I am doing this to get you idea how we use sub-circuit in our main circuit. So this one is working as a full adder. Here, that's the thing I need to explain you before going to design our 4-bit adder. Okay, let's design 4-bit adder. I'm going to delete these things. It is not needed. And also this one and these lines. Okay, firstly get our inputs. You know, this is a 4-bit adder. That means we add two numbers. In the first number, we have 4 bits. And the second number, we have also 4 bit. Let's design that inputs. Firstly, get A. Oh, we need to downside this so that set it to south. And I labeled Control C, Control V, Control C, Control V. I will copy these things and I am labeled this one is as A0. Oops, I need to set label to upside. For that I set it to north. This one is A1, A sorry A3, sorry A2, A3. So this is our first number. Let's design second number. For that I copy this thing and put it to here and set this to B0, this one to B1, yes, this one to B2, this one B3. Okay, now these are our inputs. Okay, now design our outputs. So we need only 4-bit outputs. For that, set it to here and change it to north and Control CV. I'm just copy these things. Okay, so I'm naming this digit as let's consider the output is sum, so let's call it to S. This is the S0. Oh, we need to set these labels also downside. For that I set it to south. This one is S1, this one is S2, this one is S3. Okay, now our inputs and outputs are completed. Let's get this 4 sub-circuits, because in this one sub-circuit it is add together A and B 1 digits. So here it is added 1 bits together. Okay, let's get 4 this full ladders. This one, this one, this one. Now there is a 4 full ladders. So this is the easier things. When you design complex circuits, it is very easy to use same sub-circuit again and again. Okay, let's add first digits together. That means in A number first digit and in B number first digit. For that, we are get this number from here and put it to this A position, and get this number from here and put it to here. So this is B position, this is A position. Now this thing is added together, and here you can see sum. When these numbers add together, it is output the sum. We can put that sum to our S out. That means sum field first digit. This is count. And in the first position, we have no carry input. For that, get it to here, I am set it to 0. Let's input here and named it as a carry input. We have no carry input, for that it is default 0. Now you can see there is a carry out also. When these numbers add together, there may be a carry out. For that, we are going to pass this carry out to next adder. You can see here carry input. In here we pass this carry out to in this adder carry in. Now we are going to add our second digits together in A number and B number. I am getting these things from here. Set it to here. Get this number from here. Add it to here. Now you can see these numbers are added, and the sum of these numbers is go out, and we put it to S1. Now the output of this carry out, we are going to pass it to next adder carry input. Next, we are going to add these numbers together. This A and this B. Let's select this. We can select like this and move it. Okay, let's now the output of this adder is going to be a third digit of our sum. Let's pass it to here. Now the carry out of this number is going to be a input of here. Then let's put our fourth number is here, and here also. The sum of this is going to be a third number of our this circuit, and here this carry out is we put as the output to here. Carry out. Now this is the circuit of our 4-bit adder. Let's simulate this. When we add 1 and 1 together, it is 2. That means it is indicate 1 and 0. When added 3 and 1, it is going to be a 4. That means here you can see it is indicate like this way. When we add 5 and 2, it is indicate 7. So you can see it here. So when we add 5 and 3, it is indicate 8. So you can see it is perfectly working. I think you got idea about how to design 4-bit adder using full adders. So these are the thing I need to teach you in this video. Thank you guys. See you in my next videos. Have a good day.